So let's talk about what happened with fundamental theorem calculus. I remember we talked about first. Let's talk about geometric understanding, right? Did we did this yesterday? I don't know if we did, but just assume that I did. So let's just say if I have integration 2x dx, if I break up the small part, I got this, right? I can do it geometrically, right? If I do it geometrically, I have a few different ways to approach it. I can approach it as a trapezoid or as 2 to 5, but the slope is going to be 2. So this is basically algebra 1 technique, is you can graph the line with 2x with slope of 2. So therefore, I will have the line connected from here to here, and but I want to only find out the area between 2 to 5. So that's basically here. And this one is going to be 3 times 4. That's equal to 12. And this one's going to be 3 times 6 times 1/2. That's equal to 9. So therefore, it's going to be 21. Now, with that being said, yeah, 21 geometrically. But what if the function is not a straight line? That becomes a difficult part, right? If it's a parabola, then obviously it's not going to work because parabola has a curve. It's not a triangle. It's not a circle. It's not a semicircle, quarter circle. It could be any of those functions. It could be a sine function. Could be anything. So what if that's the case? Well, that's the case. Then we have to know what is fundamental theorem of calculus. Well, what's the integration of f of x dx between a to b? Well, usually when I take integral of something, I'm gonna get big F of x between b to a. Does that make sense? If I take integral of non-capital, just becomes integration. So now you realize I draw a straight line. That means that's not you already take an integral already. Now you just have to get in process of plug in. So therefore, that's going to be f of b, substitute a b, minus substitute a a. Did we talk about this yesterday? Yeah. Okay. So, sorry, then I'll just talk about again for the video. So integration of 2x dx between 2 to 5, basically that's just equal to x squared to 2, and the 2 is going to cancel out. So that's equal to the 5 squared minus 2 squared. That's equal to 21. And that's also proof the theorem, the property. The property says what happens if I invert it. I says, well, arithmetic, it will show up exactly the same way. Now just because 2 to 5, so it'll be 2 squared minus 5 squared. That's equal to negative 21. That proves that property is something as a fundamental theorem calculus. You can switch the boundary, just switch the values, switch the evaluation. With that being said, okay, what would it be if I have different type of questions? Yeah, so I can say, what happened if I have an equation of, give one that's kind of special. Let's see what we have. Integration, fundamental theorem. See which case we like. I'm just gonna made up one. So I'm gonna say 3x to the actually I'm gonna do 2x to the third, right? minus maybe 2x to the 2 to the maybe 3x to the 2, maybe 5x to the 2, like this. Sorry, but can I make mine? And let's do between 1 to 5. 1 to 5 is too big, let's do 3. You just have to focus on arithmetic. What's integration of 2x to the third? Huh? What's integration 2 to the x to the third?
1 over 2 times x to the 4th.
Yep, so it'll be x to the 4th, 2, and 4, right? Minus 5x to the third over 3. And then draw a line. That means I already take integral. I haven't evaluated yet. And that's equal to 1/2 times 3 to the 4th minus 5 to the 3 to the 3rd over 3 minus what? Minus 1/2 minus 5 to the 3rd, right? That looks pretty disgusting, but that's 81 over 2 minus 3 to the 3 is 27, I think. 27 times 5, 135 over 5. Oh, over 3, sorry. Am I going too fast? Minus, let's say 1/2 minus 5 over 3, right? Are we okay here? So I don't like to convert fractions. Wait, did I do something wrong here? 27. Yeah, okay. So basically I can probably simplify this to an integer, but then I have to combine fraction again, so I have to change the same denominator, and I have to change the same denominator in this case. Now for me, I don't like to combine common denominator. I like to do this. This means 81 over 2 subtract 1/2. Does that make sense? If I do it this way, I believe it's going to be slightly easier. So that's going to be what? 81 over 2, which is 40. Does that make sense? And I just work out a second one, so it'll be negative 135 over 3 plus 5 over 3. So it'll be what? Minus 130 over 3. And then I'll multiply by 3 over 3, so that's equal to 120 over 3 minus 130 over 3. So that's equal to negative 10 over 3. And that's my evaluation. Why? Because I don't like to change the denominator back and forth. I just want to change once, which is the last step I changed it. Oh, that was hard, but it was not hard. It was supposed you had to do both, right? So I would just do once, and then I'd become more efficient. How do I know if my answer is correct? Then I'm gonna go into the decimals. You can do it. You can do the things. Just type in int. Int is gonna show up as integral. Okay, and then between what? What value? 1 to 3, right? Is that right? And what was the function? 2x to the cube. That's obviously wrong.
Minus 5x squared.
Minus 5x squared.
And dx.
And then dx. So obviously you need dx here. And you also can do it on your integral too. And you probably need a parenthesis, I think. That's equal to negative 3.33. negative 10 over 3 is negative 3.3333. And that's how you check the integrals. Does that make sense?
Why do you subtract the 1/2 minus the 5/3 in the second proof?
1/2 minus what?
5/3. Why do you subtract that from?
I plug in 1.
Oh,
I plug in
okay, yeah.
I plug in 3 into here, subtract, I plug in 1
Yeah.
into here. Does that make sense?
Yeah.
Okay. What happens if I got a integration of this, right? I want to see if you guys can work out arithmetically. So I will have 2 minus x times square root of x dx between 1 to 4. Let's see if you guys can do it correctly. Can you tell me the first step you would do?
Change the x to 1/2, the square root of x to 1/2.
Okay, what do you do after that?
Combine it,
How do you combine?
like make it into, combine x to 1/2 or distribute it.
Distribute, that would be a right word. Okay, so of course you cannot do integration of each, no, that would be wrong. But you can distribute and use power rule. And hopefully you can work all the way through. The math is kind of It's not gonna be pretty.
do you multiply by 5 over, what is that? You multiply by 5 over 5, or is it 5 over 3?
What?
Did you multiply by 5 over 5? Is that what you did?
Yeah.
Okay.
I need a common denominator.
Oh, sure.
Question? You understand? And I mean, just arithmetic. Don't make mistakes. Be very precise of what you're doing, and stuff like that. One more things. Originally I was gonna cover absolute value. How much time I have? What time we get off here?
28.
28?
Yeah, 9 minutes.
Okay, so I do have time to talk about absolute value. So how do I do absolute value of, I don't know, 2x minus 3 between -4 to 5 dx of absolute value? Now, for me, that I'm gonna teach you how to do it algebraically, but algebra, it's kind of pain in the butt. I'm gonna be honest with you. But which one is it? You still have to find the x-intercepts. So it'd be 2x minus 3 equal to 0, x equal to 3 over 2. Why do you find x-intercept? Well, you find x-intercept that you can, based on that x-intercept, to draw out the point of piecewise function, which is here is going to be -3 over 2. Actually, -3 over 2 should be right here. -3 over 2 should be right here. And we have some type of the absolute value here. We have some type of absolute value here.
Wait, what do you mean -3 over 2?
Should it be like -2 instead?
Yeah, I don't know why I write down negative. So it'd be 3 over 2 here. So then how if you were to do it normally, this is what would you do? This side of the function is called 2x minus 3 functions, and this side is called -2x minus 3 functions. Does that make sense so far? Because there's just piecewise function. One is the positive version of the absolute value, one is the negative version of absolute value. So then if you're going from 5 to 3/2 of absolute value of, now absolute value just change into piecewise function now, and I'm going to plus negative of 2x minus 3 dx between -4 to 3/2. Then that will be an evaluation. The evaluation, this is pain in the butt. So you have to work out each individual one, and then you have to work out. So let's see if this one's going to be x squared minus 3x between 5 and 3/2. And I'm just going to take it out, so it'll be minus sign instead of plus sign, of 2x minus 3 to the 3/2 and the -4. Does that make sense? And then I'll plug in. So kind of the work kind of a lot. So it'll be 25 minus 5 times 3 is 15 minus 3/2 and then square minus 3 times 3/2. So you see that work is quite a bit, right? And it's really easy to make mistake. And then minus whatever result here, which is, I'm sorry, this one's wrong. This one, it should be x squared minus 3x also. So it'd be 3/2 square minus 3 times 3/2. And there is a minus sign of -4 square minus 3 times -4. And you're going to simplify this. And just a lot of arithmetic, right? I'm not going to simplify this because I personally not a big fan of simplify all this stuff. And if I ask 20 students, probably one student can simplify correctly. So let's talk about what will be an easier way to approach this problem, right? Would you want to approach an easier way? Okay, so I'm going to show you. We know that it's going to be at 5. So we know it's going to be like, it's going to be at 5 here, and also -4. We don't know what a y value is because the line I didn't draw by a scale. I should have. But I can figure out how high is the triangle by plugging phi in there. And it should give me like something like, it should give me like 8. So 1, 2, 3, 4, 5, 6, 7, 8. So it should give me like this. Does that make sense? Do you know how I got 8? I plug in the phi into the 2x minus 3, right? So this one is going to be what? Well, it's from 1.5 to 5, so roughly is 7/2 here. So for this triangle, it's going to be 8 times 7/2 times half.
1 second. You should go back 1 second. So, how did you get 8 again?
I plug in 2. I plug in phi into the 2x minus 3. Because I just want to find out how high the triangle is.
That would be 7, right? 10 minus 3.
Oh, 7, you're right. So it's going to be 7. So this one is going to be 7. So my first drawing was pretty good. So it'll be 7. And how about if I want to find out this height here? What do you think that is going to be?
It's the same, right? Plug into negative.
Opposite.
Plug in -4. So it'd be -8, right? -3, so it'd be -11, right? So first of all, I'm going to add up to this 702 times 1/2 plus the other side is going to be 11. It's not -11, it's 11 because negative. It's going to be 11 times the width. It's from 5 to 3/2 from -4. Why did I draw it like this? It should be like something like this, right? From -4 to 3/2 is what? How's the width?
Do you admit it for?
How's the width?
-4 + 3/2.
So it'll be 6.5, right? No, 5.5. So it'll be 11/2 and times half. So this calculation is way simpler because this is 249 plus 2 of 121. And actually it work out pretty nicely. 160, 170, I think. So it'll be 170/2. So roughly is 85. And if you work out this, you're gonna get 85 as well. Except the work is so much more complicated. If you do it geometrically, then it's much better.